The diagram shows a sketch of the graph y equals f of x. The graph passes through the points -1, 0, and 7, 0, and has a maximum point at 3, 2. Sketch the following graphs using a separate axis for each graph. In each case, you should indicate the coordinates of the stationary point and the coordinates of the points of intersection of the graph with the x-axis. Okay, so looking at this graph and starting with part I, y equals f of x plus 4. This is a transformation inside the bracket, so it's going to be a transformation on the x value. That means that because it's inside the bracket, it's on the x value, it's going to do the reverse of what it says. So what we're going to do is, instead of adding 4 to the x values, we are going to subtract 4 to the x values. So it's going to be a translation of -4 places in the x direction. Algebraically, we can write this, if I've got f of x plus 4, algebraically, I can write this as -1, 0, 3, 2, and 7, 0. These will go to the points subtracting 4 from the x value, -5, 0, -1, 2, and 3, 0. So when I sketch the graph, it's still an upside down kind of quadratic shape. It still has 2 roots. So if I mark on the roots, I have -5, 0, and then I have the other root, which is 3, 0. I can mark on the maximum up the top here, which is -1, 2. And so what I know is that the y-axis is to the right of the -1, but to the left of the point 3, 0. So the y-axis, I'm just going to draw in there. We don't need to worry about where it cuts the y-axis, it's just the other points. Okay, part 2, y equals -2 f of x. Well, there's actually 2 transformations happening here, so it's a bit sneaky on this one. But -2 f of x, what I'm actually doing is I'm stretching all the y values because it's outside of the x function, so that means we're working on the y values, and stretch all the values with a scale factor of 2 because outside acting on the y values does exactly what it says. But also I'm going to reflect in the x-axis because all the negative y values are going to become positive and all the positive y values are going to become negative. So the minus is a reflection in the x-axis, and the 2 is a stretch in y, scale factor equal to 2. So algebraically, considering the points, if I have -1, 0, 3, 2, and 7, 0, when we transform these points, I'm essentially multiplying the y values by -2. So the first point remains the same. The second point, I multiply the y value by -2, so I get 3, -4. And the last point remains the same. So when I sketch this graph, now I flip the graph upside down. So it's the other way round. The roots are still at -1, 0, and 7, 0. The minimum now, however, is at 3, -4. And here's my y-axis. Okay, so part B, it says hence write down one root of the equation f of x plus 4 equals -2 f of x plus 4. So what we're actually saying here is that if I take my -2 f of x and translate it 4 places upwards, what I'm going to end up with is this curve here, where it touches at 3. So just sketching that in here. So this is my curve minus 2 f of x plus 4. And it's equal to the curve f of x plus 4. So this is this other curve here which comes up and comes down, and it's supposed to be through the same point here. So here is one root of the equation, here is another root of the equation. I'll put in the y-axis around about there. Now this root of the equation at the top here I can't determine, but the other root of the equation is that they both pass through the point 30, so I get that the root is x equals 3. Okay, so let's see how we get the marks in this question. If you have got a concave curve that is like kind of like a sad face direction, and the y maximum is 2, you can have a B1 mark. If you've got the x coordinate of the minimum is -1, you can have another B1 mark. And if you've got both points of intersection with the x-axis correct, you have a third B1 mark. Now, if in part 2 you have got now a smiley face curve and that your minimum happens at x equals 3, you get a B1 mark. If you then get that the y coordinate of the minimum is y equals -4, you get another standalone mark. And again, if you've got the points of intersection with the x-axis, then you get a third B1 mark. Finally, part B is just a correct answer only, B1 mark if you have correctly deduced that the root of this equation that we're given in part B is x equals 3. Well, I hope that all made sense and that you were able to mark your question.